Hello everyone and welcome to Global Analytics with Cosmos DB and Azure Synapse Analytics. This is a session part of the Data Platform Summit 2020 virtual around the clock. I'm really happy to be joining you today, recorded, but I can assure you right now on the chat I am live. So as we go along, if you have any questions that you want to discuss, regardless, at the very end, we will also have a period just for Q&A. And of course, after the session is over, I'm 100% available for any follow-up that you want to do. So allow me to introduce myself. I have been a DBA and consultant for 13 years at this point. I used to work at HP in Costa Rica, but I am now a principal consultant at Pythian in Ottawa, Ontario. I am honored to be a Microsoft Data Platform MVP. Feel free to reach out to me over Twitter @warchav is my handle. Check out my website createdatapros.com, and if you have any sort of question after the session that you want to send me, you can go ahead and use my email warner@createdatapros.com, and I will do my best to get back to you in a couple of days max. All right. What is the agenda for today? So we're going to talk about the concepts and the steps to visualize global data using Cosmos DB and Synapse, and why this combination is particularly very powerful, because it makes it really easy to analyze data that you might be originating from anywhere in the planet. So I'm going to cover Cosmos DB, especially Cosmos DB, because really the global multi-writer replication of Cosmos DB is the key piece of this solution. But I'm also going to cover Synapse, I'm going to cover the Synapse Link, and then I'm going to use Power BI to create just a couple of visuals to show you how we can have Power BI auto refresh as well with the data that is coming from anywhere in the planet. What are we building? So we're going to have 3 demo sections in this session today. And the first one, we're going to look at the Cosmos DB piece. The second one, we're going to look at the Synapse piece. And then the last one, we're going to look at the Power BI piece. But basically, we're going to have a Cosmos DB account that is split between Canada and Japan, both regions allowing to write to them. And then we're going to have a Synapse Workspace that, using the Synapse Link, is able to pull that data into the Spark pool or the SQL pool. And then we're going to have Power BI connecting to the SQL on-demand pool. This is the new engine that has been created for Synapse to do SQL queries on demand. And using this engine, we're going to pull that Analytical Store Cosmos DB data into Power BI. So let's cover Cosmos DB first. Fundamentals. I'm not going to dive deep into Cosmos DB, but I figured that some people here might not be 100% familiar with it, so we should just cover a few fundamentals of Cosmos DB. So Cosmos DB is Azure's NoSQL database. So it is not a relational database, it is a NoSQL database that is meant for a scale out. It scales horizontally. Microsoft adds more nodes as your database gets bigger and bigger. It also has multi-API capabilities. It has a SQL API, which is started as the document DB. Some of you might be familiar with this term if you've been following Azure for a long time. And then it also implemented new APIs like the MongoDB compatibility API, the Cassandra API, Graph API, and I think it has a couple more now. It is a fully managed service. So that's something very important about it. You don't have to manage any sort of operating system. You don't have to manage any sort of deep configuration of the Cosmos DB engine. You just have to use it and let Microsoft handle the rest. And this includes the replication capabilities, which you can set up really easy in the portal. We're going to see it in the demo. You don't have to do much to be able to be multi-writer replicated all over the world. Then the other thing is that capacity in Cosmos, because it is a fully managed service, it is implemented through a concept called request units, which basically goes like this. The more request units you have, the more operations you can do per second in your Cosmos DB account. And then there are different consumption models for Cosmos DB. You can have it as provisioned, where you specify how many request units you want. You can have it to auto scale, where you specify a range of request units that you want, or you can do serverless, where serverless is basically you don't consume anything if you are not doing any operations on your Cosmos DB database. But if you do consume, then the cost per request unit is slightly higher because you're doing it in a serverless mode. Now, Cosmos DB is very important to understand its replication capabilities, because this was built from the beginning as a core design tenet of the product itself. So from the very beginning that Cosmos was being designed, it was being designed with the idea that it would be replicating data around the world. Now, first thing that was released was the read geo-replication. So you were able to specify different regions around the world, but they were for read only. You had to have one of them be the primary that would do read and write, and only one of them could be read and write, and then the rest had to be read only. Now, at this point in time, it's been probably, I want to say, a year and a half or more since multi-master geo-replication has been available. So it's not something now that we only have read-only copies. Now we have multi-writer copies as well. And then another really cool feature of Cosmos DB is that you have consistency levels that go all the way from strong to eventual consistency. So you don't have to just have one or the other. There's a few intermediate levels as well, such as session, bounded staleness, etc. For now, that's all you need to know for us to be able to do the global analytics, is that we can do multi-writer geo-replication and that we have multiple consistency levels that we can take advantage of in our Cosmos DB database. So let's talk about multi-writer replication. This is how it is implemented globally by Microsoft in terms of the internals of Cosmos DB. So I find this is really cool. I want to share with you guys. So let's look at it in detail. So let's say right here we have 3 regions of Cosmos DB, region 1, region 2, whatever, region N, right? So there's not a particular limit here. It's only limited by the amount of money that you want to spend. But let's assume that you have 3. Now across each one of these regions, you have what is known as a partition set. So let's say each one of these, it's its own physical cluster, and then they're associated with other physical clusters in the other regions. And then inside each one of these clusters is what is considered a physical partition of Cosmos DB. And then if you look here in the corner, the physical partitions have a leader, which would be the primary inside that cluster. They have a couple of followers to provide redundancy for that data, because keep in mind, again, Cosmos DB is a NoSQL database. And they also have a node called a forwarder. So that's really neat, right? So each one of these nodes has different roles that they play and that allow higher scalability of the solution. So this particular forwarder will then talk to the leader in another region, and then so on, basically creating a mesh from all these different Cosmos DB nodes around the world to keep your data up to date. Let's see it here. This is what is known as a partition set, right? So in this example, we have Europe West at the top, we have US West in the middle, and Australia Southeast at the bottom. And what happens here, for example, is that if there is a change in US West that then has to be replicated to Europe West and Australia Southeast, then the forwarder node of that particular replica set is gonna take charge of communicating this change to the leader of that replica set in Europe West and the leader of that replica set in Australia Southeast. And then from that leader, it will go into the followers and it will go into the forwarder as well. The forwarder can tell that this is a change that did not originate on its leader, so it doesn't continue the circle indefinitely. So it will stop here. Now on the other side, if the change happened, let's say up here in Europe West, Then the leader in Europe West would send it to its forwarder, and then the forwarder would send it to the leader in US West and the leader in Australia Southeast. And this happens for every single different replica set that you have in your Cosmos DB account. So that's why I mentioned that this turns into a sort of mesh of replication, where you have, for example, maybe in this particular account, let's look at the top, there is one physical partition of Cosmos DB that is doing an activity at a certain point in time, and there's another one that is idle. So the one that is idle is not replicating anything, but the one that is doing the activity is going to replicate to the other parts of its partition set, right? So different partition sets will be active at different point in times, and if changes are coming to region 2, then the forwarders here are firing up. Maybe the changes are coming to region 1, then these forwarders are firing up. The system is very dynamic, it's very flexible, so it scales really well to replicate data at high volume throughput around the world. Now let's talk about the Analytical Store. Now this is the feature that allows that Cosmos DB data to connect into Synapse and to do it in an efficient way. The Analytical Store basically is a replicated copy of the Cosmos DB storage. So we go from the transactional storage, where it is stored by records, similar to how a relational database stores data, not the column store, and into a columnar format, and this is similar to column store. I believe under the covers what is happening is that the Cosmos DB data is getting materialized as Parquet files by a different engine that Microsoft has put in there that does an automatically sync from your Cosmos DB transactional store into this columnar store. The nice thing about this is that you just have to enable the Analytical Store and it just works. You don't have to manage this auto sync process. You don't have to manage the storage. None of that. You just have to allow the Analytical Store to work, and that's it. Now let's talk about the characteristics of the Analytical Store. As I said, it is a columnar format. I believe it is Parquet that is using under the covers. So if you select specific columns, it doesn't have to read the entire record. It can just focus on particular columns. Because it is columnar as well, it compresses, and it compresses really well because all the similar data type values are close to each other. Now there is a lag between the transactional store and the Analytical Store. Microsoft says it's about 2 to 5 minute lag before data that has gone into the transactional store gets stored in the Analytical Store. It does add storage to your cost and your bill, as I mentioned before, but the nice thing about the Analytical Store is that it does not consume Cosmos DB request units. So you don't have to worry that enabling the Analytical Store is going to make your Cosmos DB solution slower, because it does not consume request units. And at the same time, when you query the Analytical Store, it also does not consume Cosmos DB request units. So querying the Analytical Store to build reports, analytics, machine learning, etc. is not going to have an impact on the performance of your main Cosmos DB transactional behavior. So let's jump into a demo now. I'm gonna check out how we create and how we use a global Cosmos DB database. Okay, I'm in the Azure portal, and the first thing that we're going to do is walk through the configuration of a globally replicated Cosmos DB account. So this is very easy to set up in Cosmos DB in the portal. Just go to replicate data globally, and I'm gonna zoom in here so you can see I have a region in Canada Central that's already replicating to Japan East. Now there's nothing stopping you from recruiting more regions into your topology. For example, if you want to add some presence in South America and you want to add some presence in Western Europe, you can do that as well. The only thing stopping you is the cost. Every time that you add a region, you add more request units to your Cosmos DB account. Now, something else to keep in mind is that multi-region writes have to be enabled, because Cosmos at the beginning only offered multi-region read replicas, but now that it allows multi-writer, then it's something that you have to enable. However, this is really easy. As you can see here, it's just a button in the portal, and then you'll be able to have here the list of all the different regions that have reads enabled and writes enabled as well. So this is how you do the global replication. This is very easy, and I will show in a couple of minutes how we handle that in the C# SDK code as well, so that you can write an application that is also using up the different regions around the world optimally. For now, let's go back here into the overview. You will see I do have a container called machines and a database called factory. And remember, the analytical store is set up at the container level. So I'm gonna scroll down here, go into my container and the scale and settings. Now, if you can see here on the settings, for my transactional store, I have the time to live set to off. In the analytical storage, you can see the analytical storage down here. And you can see here, you can't actually turn it off, but you can leave it on without a value, which is pretty much the exact equivalent. If I go ahead and turn it on, then you have to specify the time. So, and it is set in seconds at this point in time. So I'm gonna leave it on with no default, so it doesn't prune anything from my analytical store. And the other thing that is important for global replication is conflict resolution. Now here you have a couple of different options. You have the last write wins, which is the default, or you can write your own merge procedure. For the vast majority of cases, I believe the last write wins is good enough to give you what you want in terms of conflict resolution. And that is pretty much all the configuration that you need to do from the Cosmos DB account and database perspective. You have to have global replication, and you have to have a database and container that is enabled for the analytical store. And that's it. Now let's look into how we handle that from the SDK perspective. It is extremely simple as well. So you will see here, I'm going to zoom in so we can go through this. I have a method called initialize client. This is C#. We create a new connection policy. This connection policy is an object inside the Cosmos SDK. And I have an option that I set a flag that says if I want to do geo read, so geo replication just for reads, then I have to use this property called prefer locations, and I add the location name, in this case Japan East. If I want to do geo writes, so we're going to do a multi-writer scenario, which is what we're going to do for our demo, then I have to set use multiple write locations equals to true, and then I just have to set the current location in my application. So the application by default is going to connect to the primary first location that I created in my account, which in my case is going to be Canada, but at any point in time I can enable this geo writing, and then it's going to set itself to use Japan. So let's see that in action right now. So I already have a Cosmos DB client right now here that I wrote, and the demo, like I said, we're going to do is we're going to have writing from Canada and Japan at the same time. We're going to pretend that we have a factory, we have some machines on them that they're reporting temperature. So in this case, we are in Canada, and I just want to do one machine so we can keep really close tabs of what's happening. 1 call per second, and we're going to do maybe 3 calls. And then we can do a start write command. And this is just going to write 3 times into my Cosmos DB. And if I go in, I can do this query command just to see the latest record that was written. So you can see here I have my machine that is in Canada, temperature of 44 degrees, and the timestamp of when I'm recording this right now, October 21st. Okay, and the direction right now is bouncing. So it's gonna say basically the code in my application is going to do a random check whether the temperature should go up or go down, just for demo purposes, of course. Now, what happens if I go into my copy in Japan? So let me open this up, and this is a machine that I have in the Japan Azure region. So for factory name here, I'm going to set it to Japan, and the amount of machines, we're going to do the same, 1 machine, 1 call per second. We're just going to do 3 calls. Now, before we start the write test here, I do want to show this. If I go in and say the status of this particular client, you'll see even though I'm in Japan, because I haven't specified any specific region, it's gonna default here into the first region that was created on my account, which is Canada Central. So you can see right now I have a general service endpoint, and then also I have a specific read endpoint and a specific write endpoint. Okay, now I'm going to enable the geo writing, and then we'll rerun this status command and see what's happened at this point. Alright, so now let me zoom in again, and you will see here I'm using the same general service endpoint, but now that I specified on the code that I want to use Japan East, it automatically switches my endpoints for reading and writing to use the Japan East region. If I go ahead and let's run that writing command, and it's going to write 3 times as well, and we will see how quickly it replicated back into the Canadian region. If I run this query again to get the latest record that was written, we can see I already have that record that's coming from Japan written into my Canada account. So this is already working correctly. I have both regions, Canada and Japan, activated for both read and write, and I have them actively replicating to each other. So this is the piece in Cosmos DB. We are done. Now the next piece we're going to look at is how do we build that link to Synapse Analytics. Alright, we are back, and now we're going to talk a little bit about Synapse Analytics. Synapse Analytics, if you are not familiar with it, there's been lots of material that is going to be covered in this conference. As I said before, if you're going to get the recordings, you can go back and look at them and check out Synapse Analytics in more detail. But just to give a quick intro for those who are not familiar, it is a new service that bundles an entire data engineering experience in one workflow. So once we break it down, really what Synapse is it has a foundation on Data Lake Storage Gen 2. Now for those that are not familiar, that don't know why this is called Gen 2, Microsoft developed a Data Lake Storage service a while ago, Gen 1, that was separate from Azure Blob Storage, and that particular version never really took off. It was never really available in many different regions because it was just a separate service implemented in a different way. So Microsoft went back into the drawing board and said, this is not a good approach. We have 2 split services. Why don't we instead build a Data Lake Storage service on top of the regular Azure Blob Storage? And that's how Data Lake Storage Gen 2 was born. And now Data Lake Storage Gen 2 is available everywhere in the world. So Synapse takes that Data Lake Gen 2 foundation and puts on top of it both a structured MPP engine, the SQL pools. This is split into 2. The one that was formerly known as Azure SQL Data Warehouse, and the new SQL On Demand engine, which we're going to use in the demo. And this new SQL On Demand engine is serverless. You only have to query it, and then you get charged by the data read by your query. You don't get charged by provisioning capacity to it. Right? The difference here, of course, is that the SQL On Demand engine can only use Data Lake Storage, whereas the regular full-blown SQL DW engine uses the optimized column store, and it can be a lot faster, but it is more expensive. Now, in the same workspace, you also have Spark pools. That means inside the same workspace, you have the capability to do structured SQL MPP compute and big data Spark compute as well. And if you need to do ETL or transformation, you have the Data Factory engine embedded into the Synapse Workspace. And Microsoft, of course, promotes Power BI as the premium or premier visualization tool for Azure Synapse Analytics. However, there is no exclusivity to Power BI. Now let's talk about the Synapse Link. The Synapse Link is a capability that was built to optimize access to data into Synapse. Now, let's see what would happen before Synapse Link was available. Before Synapse Link came in, if I had data in Cosmos DB, I would have to put it in Data Lake Storage, and then from the Data Lake Storage, after I did that copy, I could read it or compute it with the Spark pools or the SQL pools. Or alternatively, again, before Synapse Link, I could use something like Data Factory, and then from Data Factory read the data into Cosmos, create a pipeline, and then from the pipeline load it again into either a Spark table or a SQL table or into data lake storage again. But both of these processes required to copy the data over through some sort of external process. With Synapse Link, there is no intermediate step. I just have to create objects inside Spark or inside the SQL on-demand engine, and these objects use the Synapse Link to directly connect to the Cosmos DB Analytical Store. So this is very powerful because it saves me from having to copy the data over. It saves me from having to create a pipeline or an Azure function that does the copy of the data. So that lowers the management overhead as well, and it makes the solution really to implement, really quick to implement. So we have the ability then to do Spark integration by using what is known as a linked service. A linked service is an entity that we define inside the Synapse Workspace, and we are going to look at that in the demo. And with the use of that linked service, then I can do that straight up connection from the Spark pool into the Cosmos DB Analytical Store. If I want to do T-SQL integration, then I can have an open rowset call, and we'll look at that in the demo as well. And using that open rowset call, I can have my SQL on-demand pool connect to Cosmos DB and then expose that data out from the Cosmos DB Analytical Store directly through an open rowset query, or the way that I prefer to do it, to expose it through a view so that we hide the open rowset inside the view definition. Now let's think about, in this new world of Synapse Link, then how does the ETL actually work? Well, let's talk about extract, for example. The extract phase actually happens automatically by enabling the Analytical Store, because Microsoft already has that automatically synchronization process that will take data from the transactional store in Cosmos DB to the columnar optimized Analytical Store that is inside Cosmos DB. So that's where the extract step happens, and it is completely automated. We just have to enable the Analytical Store. Now the transform step, it's up to you whether you want to transform it or not. Using either the Spark pool or the T-SQL on-demand pool, you can do a select from then the Cosmos DB Analytical Store and then do whatever you need to do to transform the data, whether you want to create more columns, reduce columns, concatenate, whether you want to analyze or compute averages, mins or max. It's all up to you what you want to do. And then the load step, again, it's up to you. If you have a really complex query that you run against your Cosmos DB Analytical Store and you don't want to have to keep running it over and over, then you can materialize these results. You can materialize them as a Spark table. You can materialize it as a Delta table inside Spark. You can materialize it as a T-SQL external table that is used by the SQL on-demand engine. But it is optional. It's up to you. You don't have to load the data from the Analytical Store into data lake storage or into T-SQL storage to be able to transform it, right? The transform and the load can happen directly if you need it to happen. So let's go into a demo again, into creating and configuring the Synapse integration to Cosmos DB through that Synapse Link. Okay, I'm in the Synapse Workspace, and the first thing that we're going to do is check out how we create that linked service from Cosmos into Synapse. Then we're going to check out how we link up if we want to use that Cosmos Analytical Store from the Spark pool, or if we want to use it from the SQL on-demand pool. So first thing, we're going to go into Manage. You see here linked services on the side, and I have the list of all the linked services I got on my account. Now, linked services are any sort of service that lives outside of the Synapse Workspace that you're going to be using to bring data into your workspace. Now you can see here I already configured mine that I'm gonna have for my demos, but I'm still gonna show you how you set them up because it's really easy. So you just go ahead, click on new, and then you just have to go ahead and search. And now I get the two options here. We have compatibility with the SQL API or the MongoDB API for Cosmos DB. In my case, I only have databases on the SQL API, so I'm gonna go ahead and select them, and then it's really easy to actually link them up. As long as you have access to them, you just have to select the right subscription. In this case, for example, I can select this subscription, I can select the account name, and then I'll just wait here for the GUI to load up the different databases. And you can see I only have that one factory database, and that's it. At that point in time, I can save the linked service if I wanted to. Now, I already did this, so I'm not going to do it again. I'm just going to discard the changes. And then if I go back here into the data portion of my Synapse Workspace, you can see if I go to linked and I open here Azure Cosmos DB, I can click on it and I have this machines container that is here in the Cosmos DB as a linked service. And now one little cool tip here is if you see this icon that has the 3 bars there like a chart, that means this is a container that is enabled for the Analytical Store. So that's a really quick, easy way to just look at it and figure out whether you have a container that is using the Analytical Store or not. Now, let's see, how do we consume it now from Spark? So first, I'm just going to do some simple things here in Spark. I'm creating a database called Cosmos Links. That's just basic vanilla Spark SQL. And then here's where the magic happens, which is really, really cool because it is incredibly simple what the Microsoft team has done in order to be able to connect Spark to that Cosmos Analytical Store. So all you have to do is specify a few options here. So first, we gotta create a table that is going to represent our Cosmos container, and you give it any name you want, and then you have to use this provider called cosmos.olap, and then the options for it. And this is where the magic happens. Using this provider, then Spark is gonna go out using the Synapse Link into the Cosmos DB Analytical Store and pull the data in when we reference this table. Now there's just a few options here. As I mentioned before, the linked service is the one that we created before, so I specify the name. Then I have to say the container that I'm interested in bringing in, because it's the machines one, in my case, the one that I just showed in the previous demo. And now there's a preferred regions option as well, and this is very important because keep in mind that if you're using Cosmos DB global region, each global region has its own copy of the Analytical Store. So you want to use your Cosmos DB copy that is closest to where you have your Synapse Workspace so that your latency is as low as possible. So in my case, actually, this Synapse Workspace is in the East US region in the States. So it doesn't make sense for me, of course, to pull the data from my Cosmos DB Japan Analytical Store, even though both of them are in sync. Because keep in mind, all the reading and writing replication is also synced up in the Analytical Store. So you can use either one of them in terms of the content of the data. But if I use my Canadian region, it makes a lot more sense, obviously, to move the data from Canada into the East USA region than to do it from Japan into the East USA region. So I already ran this command. And then after you do that, then it is very, very simple because you can just run any Spark SQL command or any PySpark command or any Scala against that Spark table that I created called Cosmos Machines, and there is no differentiation at that point against a native Spark table or this table that gets materialized through the Synapse Link. So I can just go ahead and run this cell in my notebook, and we can see the job is in progress now, and we're gonna wait for it to finish. And here we go. So using this Spark table that's using that cosmos.olap provider, I can easily select the machine and a factory name and calculate the average temperatures for each one of these machines, one in Japan and one in Canada, which is the ones that we populated in the previous demo. So it's all good from the Spark perspective. Now what happens when we try to consume this data from the SQL on-demand engine? Is it the same? Well, not really. So the implementation is actually very different at this point. Personally, I'm not a big fan of how it's currently implemented in the SQL on-demand pool, but I'm hoping that the Microsoft team is going to work to make this a little bit smoother. And for now, at least we have a solution if you don't want to use Spark and you just want to use the SQL on-demand engine. So what I recommend is that you encapsulate the SQL on-demand access through a view. And the reason for this is that in order to access that Cosmos Analytical Store, you have to do an open row set command. And this open row set command is going to pass in Cosmos DB as the provider, and then you gotta pass in a Cosmos DB connection string in the open row set. So this is the part that I'm not a huge fan of. I believe that it would be nice if we just pass in here the name of the linked service, and then using the metadata of the linked service, we could use that open row set command instead of having to replicate basically here the information that we already have in the linked service on the workspace. But right now, this is the implementation that we have. So we have to specify the connection string. So we have to say which account it is, what database, what region, the key for your account, and then the name of the container, which in my case is machines. Now, optionally, you can also specify the schema if you want to do some sort of conversion, or you only want to take some columns out of the analytical store, then you can specify the schema here as I have in my open row set. Now, something to keep in mind, for example, is that my temperature read timestamp, they're actually date-time offsets. They have the date component, the time component, the time zone component, but once they get stored in Cosmos DB, if I try to extract them out through this provider, then they're gonna come out as strings. So I want to be able to show them back as datetime offsets to give them the proper data type they have, because if I'm going to be writing SQL queries against them, then I want to be able to use any sort of functions, for example. And further down in the presentation, when we're consuming from Power BI, I want to be able for Power BI to recognize that it is an actual date time offset value. So what I do here is I take advantage of the fact that I'm encapsulating this in a view, and I just throw in a convert so that we turn these string values of the read timestamps of the temperatures into date time offsets. Okay, and this works fine. Now, once the view is created, I can just go ahead and select from it. For example, in this runtime, this I'm using SQL on demand. Keep in mind, this is not in the SQL data warehouse pool. It's a SQL on demand, and you can see I get my results right away, and I don't have to do anything else here. So after the view is defined, then I can just select from it like a normal table, and the results will come right back. So this is also the approach that I recommend if you are going to be using this for now and exposing these tables for your end users. For example, if you have some analysts or some data scientists, I wouldn't want to give them the information necessary for them to do from open row set commands, because then you would basically have to give them the connection string of the Cosmos DB database. I wouldn't want to do that. What I would do is that I would use my administrator access to create the views that encapsulate these analytical store containers, and then only provide access to my end users to the views themselves, so they can select from the views, and that's it. They wouldn't be able to run an open row set directly. Okay, at this point then we are good. We know how to access from Spark. We know how to access that Cosmos DB analytical store from the SQL on-demand engine. But what happens now if we update something? Okay, so I have right now the most recent records. If you see here, we're ordering by temperature read timestamp. The most recent records are in Japan. So what happens if I go in and I do another write from Canada? This is the Canada utility that I have right now. If I run the latest, see if I can find where is the latest query that's happened, or the latest record that's been written. I see the latest record that's been written is now again in Canada, because that's where this one is connected to. However, if I run this again, we'll see I still get Japan. So always keep in mind, this solution is not instantaneous real time. It is near real time because there is certain amount of lag, but it's not too much. So right now the Microsoft team, remember, they say will be from 2 to 5 minutes that it will take to replicate from that transactional store into the analytical store. So this is not going to happen immediately. In a few minutes, this will finally go in. These 3 new records from Canada will go into the analytical store, and then they will be accessible through the Synapse integration, either the Spark one or the SQL on demand. It doesn't matter which one you use, they have the same lag, because the time that you're waiting is for the Cosmos DB records to move from the transactional store to the analytical store. There is no movement into the Synapse Workspace, so that's not the issue. Is not with Synapse, it's just the time lag to go from transactional store to analytical store from the Cosmos DB side. Okay, final piece of our session for today is the visualization. Keep in mind, as I mentioned before, Microsoft obviously will want you to use Power BI, but you don't have to. Any of the big data viz players such as Tableau, Qlik, Looker, they all support Azure SQL, and this is the way that we can connect to that SQL on-demand engine. For any of these tools, it doesn't matter that you're using the SQL on-demand engine. They just think it's a SQL database and that's it. And I'm going to show you how in using that Power BI desktop. So in the demo, we're going to use Power BI desktop, and you will see that I select Azure SQL database as my source of data, and I just use the SQL on-demand endpoint. So it doesn't really know that it's talking to SQL on demand. It doesn't really care. It doesn't really matter in the end. And it's the same for any of the other tools. So that's something really important, because a lot of people have this confusion that if you're working with Synapse, you have to work with Power BI, and that is not the case. And in this case, the Power BI scenario that we're going to build is that we have that Cosmos DB account that is geo-replicated Canada and Japan, and then we use the Synapse Link through a view doing the open row set in the SQL on-demand pool, and then we simply have to let Power BI access that view. And from Power BI's perspective, it's just a SQL view. It doesn't know anything about what's happening underneath, about SQL on demand, about Synapse Link, about Cosmos DB multi-writer geo-replication. All that complexity is hidden to Power BI, is just exposed as a view, and in the view, Power BI gets the data, and from there on, the whole process is just the same as if you were working with any sort of SQL database. So let's check out the demo of building the Power BI visualization using the SQL on-demand engine. Okay, I'm Power BI, and we are going to go and connect into our SQL on-demand pool, and we're going to be using our Cosmos DB Analytical Store view that we created in the previous demo to make some Power BI visualizations, and we'll see how we can make it refresh and change as the data is changing as well. So first we're going to go over to get data, and in order to connect to the SQL on-demand engine, we are going to look for Azure SQL database. So you can use Azure SQL database as the type of connection that you want to do, and here we have to specify the server. So how do you find the server? I have a Synapse Workspace, but how do I find the server to do this? Okay, so we're gonna have to go back into the Azure portal, and then if you look at your Synapse Workspace overview page in the Azure portal, you will see here there is a SQL on-demand endpoint. I'll just copy that endpoint, and I can go back now into Power BI. Let's try to get data again, and go to Azure SQL Database, click on Connect, and we can see I specify the server and the database name. In this case, the database that I have for SQL on demand is demos. Now there's two ways to import data into Power BI, or to work with data into Power BI. One is to import it into the workbook itself, and the other one is direct query. Now if I just import the data into Power BI, you can do this, but then the data is living inside Power BI, and then you have to set a refresh schedule where Power BI is going to go ahead and bring more latest data in, and then your visualizations will refresh. The other option is to just do a direct query and set a dashboard to refresh at a particular interval. So that's the option that we're going to select right now. Now you can see I have all the different tables I have created inside my SQL on-demand engine. I'm going to go ahead and select this Cosmos Machine Records table. Technically it's not a table, it's actually a view, and the view is looking over the Analytical Store, but we can see here that we can get the data properly from Power BI, so we just go ahead and load. Okay, so now that we have the data here, we can see Power BI is able to read the fields as well from that view, because for Power BI's perspective, it's just a view in a SQL database. All the underlying complexity of the Analytical Store and Cosmos DB and the open row set, all that has been abstracted away from Power BI, and we are simply giving it a view to work with, right? So I'm just gonna go ahead and do, for example, what we could do right now. We could create a line chart, and then, for example, for the data, we would want to have the different temperature values. So I'm gonna put the temperature there. And let's say for the legend, we could have the factory name. So we would have the temperature in Canada, in the machine in Canada, and the temperature in the machine in Japan, for example. And for the axis, we're going to use the capture time, the timestamp of when we read that temperature. So just go ahead and put that in there. And we can see we have both lines, Canada and Japan. Now if I wanted to, for example, I could filter down this visual a little bit more. Let's say I want to have two, because I'm going to create a dashboard. So I want to have actually two line charts, because I have Canada and Japan. So I want one for each site. So we can filter easily here in Power BI and just say, no, I just want to have Canada here on this side. And then I'm just going to go ahead and copy and paste this line chart, move it side by side. And I'm going to change here the filter from Canada into Japan, and deselect Canada. And it should refresh in a second. And now we can see here I have Canada and I have Japan. And if I wanted to, at this point, I could just simply publish into the Power BI service, which I already did. So let's go into the Power BI service at this point and discuss about the dashboard. Okay, I'm in the Power BI service, and you can see I have a Cosmos Link data set. I have the Cosmos DB report, and I also have the Cosmos Link dashboard. So the data set, of course, is where it stores all the definitions of the model that you created. In this case, we just connected into the SQL on-demand database and pulled out that view that we created for that Cosmos Analytical Store. And then in the report is where I have the visuals that I created in the Power BI desktop that I then published. Now keep in mind that the report is not an auto-updating visual. Reports, you need to refresh yourselves with the latest data. And there's a button right here at the very top that says refresh. You can press it, and then the report will update itself with the latest data from the source. And you can see it adjusted slightly here for a few more data points that I inserted before I started recording the demo. But just keep in mind the report view does not update automatically. In order to provide automatic updating, you need to pin these to a dashboard, and that's just the way that Power BI works. If you're using another tool such as Tableau, Looker, Click, or whatnot, you have to look into that tool and how you specify the refresh behavior in that particular specific tool, right? This is just the way that Power BI works. But keep in mind, any tool that you use, as long as you're able to do a connection to an Azure SQL DB, you can just configure it the exact same way I just did with the Power BI desktop, and it will work. Now I'm gonna head back into my workspace and get back into the dashboard, and you can see here in my dashboard as well, it's still using some cache data. I'm gonna go ahead and manually refresh the dashboard tiles. We see they refreshed as well, and now we have the few extra points that I added as well, like I said before I did the demo. Now this is a manual refresh. Again, I just go here into the actions menu, and you can see here where it says refresh dashboard tiles. If you were to share this dashboard with somebody, anytime that they want to refresh them, they can do the same thing and just go ahead and run that on-demand refresh. However, there is a way to change the refresh interval so that you can provide the most up-to-date data that Power BI will allow you to do without having to wait for the user to do this refresh themselves. And the way to do this, I'll go back into my workspace. You gotta go find your data set and then go into the settings for your data set. So I'm gonna go into the settings here for that Cosmos Link data set, and you want to go here where it says scheduled cache refresh, and you see here there is a drop down that has the different intervals that you can set, right? The minimum that you can set is 15 minutes, and max you can set is weekly. So this will depend on how often your data is changing or how often you think you have significant changes in the Analytical Store that you want to refresh into your Power BI visuals. Keep in mind, every time that you run a refresh, you're going to be incurring some cost from the SQL on-demand engine, right? So if you only refresh once a day, let's say you specify daily, then you're only running one query in the entire day from SQL on demand, and your cost is going to be really low. Now if you run it every 15 minutes, of course, that's 4 times per hour. If we do the math, then that's about 96 times that you're going to be querying every day, which obviously is going to be a lot more. Now if the query is pretty small, pretty efficient, then you won't be using up a lot of resources on SQL on demand anyway, but it's just something to keep in mind. The refresh frequency is going to have a direct impact on your SQL on demand Synapse cost. Okay, now if you don't want to use the schedule refresh at all, you can turn it off if you want right here, but then you'll have to basically remind your users that they have to be refreshing all the time. Now I find that this actually can backfire, and then users are just manually refreshing all the time, and it turns up into being a cost that is higher than just having a 15-minute refresh. But other than that, there is no other configuration that you need to do, and in this case we are grabbing every 15 minutes the latest data straight from Cosmos DB's Analytical Store using the SQL on demand as the middle layer between Power BI and that Cosmos DB Analytical Store, but no data movement is happening from the Analytical Store into another intermediate service to be able to service it into Power BI. That's the really cool part. Synapse is basically allowing us to have access to all that data that is in Cosmos DB automatically without having to do much, and we're using those Cosmos DB replication capabilities to merge the data from different sites like Canada and Japan and transparently report against it. Okay, so let's do a recap of the session today. Cosmos DB offers a one-of-a-kind global multi-writer capability because there's no other cloud, no SQL database that does what Cosmos can do, with the amount of regions that are available, with the capacity to do multi-writer, or the capacity to tune the consistency like Cosmos DB offers. Second, Synapse offers an out-of-the-box analytics sandbox, and again, Synapse is another product that no other cloud vendor is offering such a tightly integrated data engineering space. The productivity that you can get by having all these tools integrated is amazing if you are doing a lot of data engineering work, big data work, or MPP data warehousing. Third, Cosmos DB's Analytical Store. It makes the product even more versatile, because that means that you don't just have to use Cosmos DB as a transactional store, but the Analytical Store, which you only have to enable and forget about, also allows it to be used for analytics in a very efficient way. Then we have Synapse Link, which makes data integration extremely easy, and right now it is being used to bring in data from Cosmos DB, but I believe the plan from Microsoft is to enable Synapse Link to more data sources, so that you will be able to have Synapse links to Azure SQL databases, for example, and be able to bring that data from Azure SQL DB without doing any ETL as well. So I'm really looking forward to see how this evolves and how much more data we'll be able to bring down the line using Synapse links. And then finally, you can use Power BI or any other visualization tool to produce near real-time dashboards that leverage data from all around the world with the same complexity of just querying a normal SQL database. As we showed there in the demo, Power BI just thinks it's an Azure SQL DB, just thinks it's a regular view, and the fact that we're using Cosmos DB Analytical Store, that we're replicating data Canada and Japan, it doesn't matter for Power BI, so that the visualization experience is still very simple to implement. All right. So that is the end of the session for today. Special thanks to Microsoft for supporting Data Platform Geeks and all the community initiatives. Thank you as well for joining to the session today. Remember, there are 3 ways to win some prizes. Post a selfie with the hashtag, give session and conference feedback. Obviously, we want to know how we did. Visit the sponsors and the exhibitors in the virtual conference hall, and follow on Twitter the Data Geeks and the Data AI Summit as well. Now at this point in time, recording is gonna stop and we're gonna go into the Q&A. I am available in the chat. I've probably been chatting already with you guys this whole time, but if there's any other questions right now, we'll just go into that part of the session. Until next time anyway, thanks for attending, and if you're watching the recording, thanks for watching.